Hey there guys, I thought I'd do a little bit of an update video. I haven't really shown the completed updated machine. I went straight from building and doing the upgrades to doing work on it. I never got a chance to really document it. So I think in this video I'm just going to go over some of the new things I've done with the machine and upgrades and all that. As well as perhaps cleaning off the table and cutting some parts. I got a couple customer projects and stuff I've got to cut out today, and I think it'll be a good opportunity to show you how I've improved the machine and made it more user-friendly. So here we go. Yeah, here's the welded base machine. I did it a while back. Finally last year got it set up, and it is super sturdy. Once I got it leveled and I locked everything in place, I mean, it is super sturdy. I love the design. It's based on Joe's original design. And even though that the sides are welded and the rest is bolted together, it really does feel good. If I ever want to secure it a little bit better, I can always tack weld where the bolt together areas are, and then cut the tacks if I ever had to take it together. But I've never really had that problem. I don't push the machine that hard. I don't have a spindle, so I can't even get the velocity up enough where it's an issue. Second thing you'll notice is I've got e-stops both on the left and right front of the machine. They're hard permanent. True e-stop enclosures, and they are mounted right to the frame themselves. I just tap them right to the frame, including all the cabling in the machine is tapped right onto the machine. Also on the left side I've got the controller bolted right onto the machine, which was not planned. I was originally going to put this on the wall behind it, but I decided to put it on the machine itself. I thought it would be nice to have a one contained unit with a whip coming off for the parallel and the power, and that's it. And the rest is contained, fully bolted to the machine, and it's one unit. I felt it was a nicer package later on. I was kind of skeptical about putting vibration and a control panel all together, but there is minimal vibration, and I've designed this control panel, and all the components are used are really truly designed to be under the same environment that I've put them in. So that's all gravy. I've also got true cable carriers on the machine now, really nice Cygus ones, and I've used steel angles and bolted those on, and some wire ducts and better cable management. I think in the future I could have cleaned this up. I underestimated, like always, with the diameters of the cables, and it still looks nice and it works nice. There's no strain, but it was still a little bit tight. I should have gone a little bit bigger. I've also hard soldered all these flying leads, which I hate on these cheaper stepper motors. It is what it is. I don't want to spend a ton of money on a servo, but I did hard solder them and shrink them all, and then put a really nice flame retardant industrial braided sleeving right back to the cable on the IGUS continuous flex cable, which I use for everything, which is shielded, by the way. So I think it's a really nice way to finish that off. Go in the back of the machine, you'll also see that I've got V-rail for everything, precision ground V-rail, and I made my own aluminum parts out of that, which I bolted to the side. I kind of thought about it, and I went back and forth, and I didn't go as crazy on the bolting as some of the other people do, going every 2 or 3 inches as recommended. I've never had an issue with this. I just didn't want to sit there endlessly tapping holes. In hindsight, I probably would have pushed this maybe another ½ inch, another inch in for that bolt pattern, added just a couple more bolts, but it still works great. I've got no issues with that. Also on the machine, once I turn it on, it'll be a little bit more apparent. But I do have proxy sensors on all axes on this machine. You'll see one right on the back of the carriage here, and those have plate targets that bolt right into the extrusion, which works out really nice. For front and back, I've got them on both sides for the Ys, so they have independent targets. I could improve on those target blocks in the future. It was just a quick fix, and works for now. But they're independent, so I can auto square when this thing gets out of rack. And it being rack and pinion, you can actually move it when the stepper motors don't have holding torque or aren't on, which is always a fear of mine. But it's nice. I do my zero routine when I turn the machine on. Auto square X and Z, and then both Ys independently auto square, and those targets are set in positions, which makes this thing perfectly perpendicular. It gives you a nice square angle, nice square 90-degree parts. So that's pretty much the upgrade of the machine. Basically cable management, welded base, precision ground V-rails, rack and pinion, true E-stops and safety equipment with the proxy sensors. Those are inductive, hitting their metal targets. And then I also put hard E-stops with rubberized endpoints. I thought was a nice feature. If those, even though the proxy sensors are fail-safe and that they're always hot, if you want to call it that, they're always on and high, so this machine will stop even if the wires break. I did want to put hard targets just in case as like a last thing, because this thing can just plow right off the machine, as you guys know, with rack and pinion if you don't have hard stops, and that's why I did that. Oh, one last thing I wanted to show you was the Z-axis. I did that in 3/4 inch aluminum. I saw one of the, I'm trying to remember the member was now, but I can't remember. One of the guys in the Joe's group, so I can't take full credit for this, had done this originally. He has a sick machine now, incredible machine. But as soon as I saw him with doing this with the Z-slide, very easy piece to mill. I don't have a milling machine. I don't have really any metal working equipment, but I was able to pull this off with a really good table saw blade. Patience and really accurate machining on the drill press, and cleaning, you know, checking for square and all that. But precision ground V-rails, I dumped the other slide. This is, you know, 10 times better. I'm so much happier with this thing. It's really, really sturdy. I think beyond that, the only thing I could possibly do is change these carriages to aluminum to make this a whole lot stronger, or metal of any kind. And that's its target for up. For down, there's obviously no target. There's just a soft limit, so it can't go much farther. But because of the heights of the tools, it doesn't really. I don't really need it. I've also hardwired the router into the panel to a solid-state relay. That's my ground for the router, because there's no ground. This is a 2-wire router. There's no ground lug on the head of this thing, so I did it anyway so I could zero my tools easier without bringing another conductor over here. This goes back to the solid-state relay, so I can turn it on dynamically with the program or with user control, but all digitally, which I thought wasn't necessary, but was a very nice feature that brought this machine out to being as modern as the rest of the features that are on the machine. So without further ado, I've got the disconnect on here, just as my other panels. Basic setup is the same. This guy's already on, so now I'm just going to turn on the machine. New addition, if you've seen my other panel videos showing this panel being built and demonstrated, is I've got the panel meter, which is really nice. So you can see just with the motors and what's going on in this panel, I've got about a 1.3 amps more or less, and with cutting and all the motors, all the axis is running, I very, very rarely peak over 5 amps, which is really nice considering that is the load of the machine and the router itself. So I get a really good digital read on what's going on in the machine, beyond just listening and seeing how the cutting goes. I can say, you know, like, oh, if I'm cutting, you know, if I cut MDF, I cut it off all the time, so I know what my limit is just listening to it. But now I truly know, oh, you know, I'm really pushing these stepper motors pretty freaking hard and I need to slow it down. So I usually don't push my luck, but there have been times when I get impatient, and then that kind of brings me right back to reality, either hearing the crying of the bit or seeing those numbers punch up there. So that's a nice little reality check when I get, you know, lazy. So I'm just going to open up this door and show you guys inside. Although I've showed this in my other video, it's kind of cool that it's actually on the machine and I can show you that way. So here is inside, everything running. Here's my little interface relays for the proxies, PMDX 122 disconnect, protected low voltage bus, transformer on the left, stepper motors, motor contactor for the whole panel, solid state relay, breaker for the whole panel, and breaker for the router. Those are independent, with monitoring on the router, so if that trips, everything goes to E-stop. Front harness wiring pretty self-explanatory, except for which is unusual. A lot of people do this setup, so I'm not going to explain it. That's a donut ring for measuring amperage or load, and that's just the back of the digital panel meter housing. Down here is just my stepper motor, terminals, relays, e-stop, touch plate, all that kind of stuff. Okay, and one last thing I want to show you before I end this video and go on to cutting on the next video with the new machine, is I would like to show the e-stops and the limits in practice, because I think it's something that you say, oh, well, that's cool, it's too much work for me, so it's not worth it. This saved my ass the other day. I was cutting something, I nest parts all the time, as you can see, stuff like under my table, and sometimes I don't cut the full sheet, but I'll leave it on the machine because I'll be cutting a lot of, say, 1/4 inch MDF that week, and so I'll come back and I'll just use the same program file so I know where I had parts and I can re-nest and not throw out material, or just put it off to the side. You can truly just use it, run the machine, keep nesting and nesting and nesting day after day until I use up the sheet. That's all cool. I forgot to grab the recent file, and I had already cut out parts out of the material. So when I laid out a part, and it was only, you know, there's only half the material left over. That's where my tabs were. It was halfway cutting through it, and I knew it sounded differently. I just hesitated, and as soon as I saw that thing pick up into the router bit, because it had nothing holding it down anymore, the tabs were in the lower part, which I had already used that material, I hit an e-stop, and that's what I'll do right now, just so you can see. Both sides of the machine, I can reach it from anywhere I'm operating. I'm always in the front of the machine, so I'm going to hit it, and you're going to hear everything go off. The router's dead. The only thing that's not dead is the computer, and that's because that's on a totally different circuit, and so it's not integrated in this controller anyways. But everything is dead on the machine. Everything is forced to reset. The software knows that the thing reset, so it will stop the parts program. It won't keep spewing. It won't lose its position. And that's the important thing, is that the software knows that what the machine's doing, and back and forth. So now I have to twist and re-engage the e-stop, right? But because I've got a motor contactor on here, nothing is going to go back on as soon as I do that. And even when I re-engage the motor contactor, I'm still in a reset and mock. I have to reset. And if I'm in the middle of a program and want to continue, I've got to hard turn on the router again, or restart from the beginning, which would do that too. But the point is that the router will never go back on when I untwist the emergency stop, which I've seen on machines without motor starters and safety prevention, which is super dangerous. Is exactly why OSHA requires a lot of this, you know, soft motor starters and that sort for table saws and stuff in a wood shop, in a commercial shop, because, you know, power goes out, the guy's cutting stuff on a table saw, turns it back on, the guy's just leaning on it, drinking coffee, waiting for the power guy to turn, you know, flip the breaker, or his power company to get him back his service. Thing goes back on without anybody knowing, or somebody laid something on the table. It's extremely dangerous. So I think that's the safest way to go. Keeps the machine safe, even though I'm the only one using it, and I don't have a button pusher here. I'm very knowledgeable, but still, I'm a human. And so last thing was the touch plate, and this is totally temporary, although it's like a long-term temporary. I have to get a connector that I can mount to the front of this. I made this little kind of L channel, if you will, to secure, like, you know, like screws and parts and a knife and slam paper and stuff. Just like stuff I could throw in front of the machine while, you know, so I'm not putting tools on the bed of the machine, which is known to happen and cause problems. Anyways, just a quick connector on this guy. But this is my touch-off plate. I machined this out of hard plastic. I actually think it's polyethylene, high-density polyethylene, same parts used in the machine. Oh no, sorry, it's PVC, hard PVC. And machined out of pocket, made an aluminum plate by hand and drilled the holes. Not super precision, like, you know, I would love to surface one of these things out of solid aluminum and precision grind it to a nominal thickness, but I don't have the equipment or want to spend the money. And for what we do, MDF, wood parts, you know, you don't need thousands, 10,000ths of an inch. You need like less than a 32nd, and that's fine for me, because it's just the depth, and it's either I cut too far to the table, or, you know, a little bit higher, which makes that skin or those tabs a little bit thicker. Not a big deal. My most important thing is I don't want to sit there with a knife cutting out parts. I just want to cut the tabs, and this thing gets me there, and that's all I need to do. Better than using a piece of paper. So put this guy on the table. Usually I work on top of the workpiece. Eventually I'm going to put a hard plate at the corner of this thing, which the software I'll show you, which I'm using now, allows me to do. This is just if you have a part that you want to put in an offset and you know, need to work farther out from the corner. I will have a permanent Z plate so that I can touch off tools the way you should be doing it. No ground. This is just a single conductor going to this guy. All this is a 2-core cable. The spindle is grounded to the same potential, the same ground as the controller, so it's all gravy. So that's that guy. I'm actually gonna take you over to the software. I'm using Jer's 2010, I think, mock screen, but it's like a whole package. It's not just a screen. He's got a lot of cool bells and whistles to this thing. Really well thought out. Definitely designed by somebody who's been working with mock and CAM software for a while, machine software for a while. So he's really thought out. I love it. I think it was $100. I can't remember how much it cost. It was worth every penny. I love the mock blue that we use, but it was getting old. I really wanted this thing. You know, needless to say, that was free. Jerry actually spent a lot of time building this, you can tell. And it's worth it. You can set up your Auto Z. I love all the icons. They're very intuitive and user friendly. I definitely recommend buying this if you're cutting parts seriously. It makes your life a lot easier. This screen is very simple, but it's packed with stuff for guys that are working with stuff, sheet material and stuff on an active basis, cutting stuff all the time. So with that said, let me just hit reset, and now we're ready to jog around. So there's my X. I'm gonna bring this guy back to home. You know, I can push the feeds pretty good on this machine. I can probably go wicked fast, but I have no need to. Even with jogging, I'm not like in that much of a rush. I'm not counting cabinet parts, where you need to punch out X amount of sheets a day to make this machine worth it. I just make, you know, do side jobs and stuff, so I treat this thing gingerly, even though I could push it a lot more. I brought it pretty close to the blocks, just so we're not sitting here forever. But I am going to do a home routine, so I can show you what I'm doing. First I'll do the Z. I'll do the X, why not? I'll do an order. X, so now you can see, hit its target, comes off softly, and then we're going to do the Y, and you're going to see both of these carriages independently home themselves. So I don't think I mentioned this, but these are home switches. I'm using them as limit switches as well. That's very easy to set up with this screen in mock in general. Okay, so now I've squared the Y. Now the gantry is perfectly square with the router head with the edge of the table. So my parts should theoretically come out square, although they sometimes don't if I screw something up. And now I'm going to do the Z. Now the Z is just going to climb up to the top, and that's my top home. So then it bounces back off. It's pretty high up there, but it's nice because it rolls out of the way of any material. Pretty much any material I'm going to put in this machine is out of the way, even with the large tools. So now I'm homed. I do this every time I turn on the machine. Sometimes every time I run a new program I home it, because it's truly an electronic or a hard reference of the machine. And the beauty of doing this, for those of you who don't have home switches, or limit switches for that matter, in this fashion, is that no matter what happens, if you E-stop, you screw it up, you break a bit, you know, if you don't tweak the machine and you don't have to rebolt stuff or anything like that, you're never going to lose home, and you can drill a hole and come right back into it without even nicking the side of it. It's amazing how accurate it is. It's truly the best way to go. I put it off for a long time, and I regret doing so, because it's not that hard. It's a little bit confusing at first to set up, and then you get it running, and then you never touch it again, and then you're good to go. So it's worth the investment. I recommend it for everybody. I've got the dust plate on here, which I love. That's a little shout out for Kent, who I think if he sees this video, he'll recognize his dust plate as soon as he sees it. This is the best shoe plate I've ever used, and probably that I've ever seen on a non-commercial machine. And I've seen the commercial machines and use them and run them, and they have even at times really clunky dust shoes. This is incredible. It is a shout out for one of our own members who makes these products, but I will attest that this is a great product. After a long time, after a lot of abuse, this thing is still holding up. It's the fastest way to change the tool without a tool changer and get in effectively. Really cool stuff. And I've got my dust collection piped in, so for MDF and whatnot, there is no dust until I get over the edge of this table. If I'm abusing the, you know, my table space, or if I'm just simply cutting to the edge, sometimes it'll spill over. That's just the nature of cutting, and that is what it is. But for the most part, there's no dust particles very little chips unless I'm doing plastic, which just loves to shoot right out of the side of the dust shoe no matter what. But it does a really good job at containing it. I'm really truly happy. That is the best dust shoe I've used so far. Anyways, so that's the machine. I've jogged it around a little bit to show you how smooth it is, and I've homed it. I think the next step is just to clean the table off. I usually take a card scraper to the side, top of this table. Sometimes when you cut it, you nick in, you leave little raised areas. So I just card scrape it, suck it up, clean it, and I'm going to put a piece of material down. I got to cut some parts, and I'll do that in my next video. Thanks guys. Thanks for watching, and continue on.